Let's look at the problems from worksheet 13. This is number 1. So in this question, it says that a variable power supply is connected to a coil and an ammeter, and the time dependence of the ammeter reading is shown on the left graph. So this is the current supplied by this power source, and a nearby coil is connected to a voltmeter. There is a voltmeter connected, and the question is draw the graph of the EMF induced in this coil versus time. Okay. So when you pass the current through this coil, it will have some magnetic field. So that's the magnetic field, which is more or less straight. Okay. And this magnetic field is changing because this magnetic field is produced by the current. We know the magnetic field of the solenoid is mu naught number of turns in this coil, let's call that 1, and current over the length of this coil. Okay, so that's the magnetic field produced by the coil due to the current, and because the current is changing, that means this magnetic field is also changing, and this magnetic field is also shared by the coil on the right side. So this magnetic field is also changing. That means the flux passing through this coil is also changing. We know flux is BA cosine theta, and if B changes, that means flux also changes. And from Faraday's law, if there is change in flux, there is EMF induced. So if we have this change in flux, that induces the EMF, and that's what we want to know. Okay, how this EMF produced in this coil is changing with time. So we know that this EMF that is produced in this coil is N times rate of change of flux. This is the rate of change of flux, and the flux is BA cosine theta over delta T, and A is the area of the loop or the coil, so it's constant, it's not changing, and the orientation is also not changing. Okay, that means cosine theta also is constant, we can pull it out. So that means we have delta B over delta T. Okay, that's E, and A cosine theta. Now this B again is due to the current, okay, which is given by that. So you can write B as mu naught Ni. In this case, this N is N1, this is N2. Okay, so this is the EMF produced in this coil. That means this is the number of turns on this side, that's N2, and this is the magnetic field produced by this coil. This is N1, so that's N2, so that's the magnetic field, and then over delta delta T. Okay, so mu naught is constant, number of turns also constant, L is also constant, so we can pull them out. N2 A cosine theta, and then we have mu naught Ni or N1 over L, and then what is left here is I, so delta I over delta T. Okay, so that means this EMF produced in this coil is equal to some constant, all these things are constant, some constant times delta I over delta T. So that means this EMF depends on how the current is changing, or the slope of the IT graph. This is I, this is T. So the slope of this graph, this curve, gives us the EMF. So that means we need to find slope of each of the parts here. So let's see the slope of this part. So this part is constantly increasing. That means the slope is constant and the slope is positive. If the value is increasing, that means the slope is positive. Okay, so let's write different color here. So let's just wait for that one. So that one is positive slope. Okay, now next part, this part is flat. That means there is no slope. Okay, slope is 0. So that means that part will have 0 slope. And in the next part, again the slope is constantly increasing. That means there is positive slope, which would be you need to see which one is steeper, this one or this one. So steeper one has higher slope. So it seems like this one is a little bit less steeper. Okay, so this one is like that, and this one is like that. So this one seems a little bit less steeper, or more or less they are same. So you can just write about the same slope. Okay, so that's for that part. And then the next part is also flat. That means for this part the slope is 0 slope. Okay. And then we have this part, which is the slope with the value decreasing. That means there is negative slope. So for that part we have negative slope. Okay. And then last one, see what color is left. Red, green, blue, black, gray. Okay, let's just use green. So again, this one is flat. That means again we have 0 slope. Okay, so we can actually connect all these lines by the dashed point, dashed line. Okay. So that's the graph of the EMF produced in this coil.